We often smile out of politeness, sometimes when you're amused, or even when you're frustrated. Ever wondered, what is it about those smiles that make them so different? We humans are usually pretty good about perceiving the smiles correctly. However, we still don't have a good idea about the low-level features of the smile that make them so different. So in our ongoing work, we try to zoom into different kinds of smiles and deconstruct them into low-level facial features. And then we wondered whether it's possible to train a computer to recognize some of the smiles automatically. The major bottleneck of this kind of research is that we need to have a lot of samples of spontaneous smiles. So for our work, we brought people into the lab. We gave them a long, tedious form to fill out. The form was intentionally designed to be buggy. So regardless of whatever they typed, as soon as they hit the button Submit, it would clear the form and bring it back to the beginning of the form. And you realize, we're surprised that a lot of people are extremely frustrated, yet they were smiling to cope up with that environment. In that snapshot, you will see two things. Number one, this participant has action unit 12, also known as lip corner pull raised, and also AU6, action unit 6, cheek raiser pulled. Based on research, when you have these two muscles evoked, you're more likely to be in a happy state. However, if you follow through the video, you will see that this person was actually extremely frustrated. So that tells you that instead of looking at a snapshot, if you look at the patterns of how the signal progresses through time, it may be able to tell you more about the expression. So we had two different kinds of smile, delighted smiles and frustrated smiles. For delighted smiles, our algorithms performed as good as humans. However, for frustrated smiles, human performed below chance, whereas the algorithm performed more than 90%. One possible explanation is that we humans usually kind of zoom out and try to interpret an expression, whereas a computer algorithm can utilize the nitty-gritty details of a signal, which is much more enriching than just kind of zoom out and look at the high-level picture. One application of our research that we're excited about is to help people with autism to interpret expressions better. Because often in school, in therapy, they're told that if you see a lip corner pull, the person is more likely to be happy. However, in our work, we demonstrate that it's possible for people to be smiling in different contextual scenarios and the meaning would be totally different. So if you can deconstruct a smile into low-level features, perhaps we can teach it to them, and people with autism may get better at it.